Hi, I'm Ahmed Saleh, and my groupmates are Saad Ahmed, Santosh Kapil, and Jay Prakash. So today we are going to present a presentation on eco-integrity system, which is like safeguarding environmental data with redundancy and tampering-proof system in IoT and LoRaWAN using the lightweight IDS and IPS AI systems. So first, let us understand the concept of this. So the main focus of this concept is the protecting the environmental data collecting through the IoT, which is Internet of Things system using the LoRaWAN, which we call long-range wireless technology, by ensuring that the data is safe from the tampering and loss. So it employs the redundancy, so meaning that the backup systems are in place, always in place. So we always have a backup of data whenever, like if something happens, or so we always have the backup of data. So this means like residency of the data. So additionally, the tamper-proofing systems, it ensures that the data can't be altered by the unauthorized parties or users. And the lightweight AI-based illustration and prevention system, which is the IDS and IPS AI, it make sure that it monitors the network for any suspicious activities and help to maintain the accuracy and the security of the environmental of the data. That was the basics, the fundamentals of the system. Can you move it to the next slide? So if we see the structure, so the typical LoRaWAN includes the end nodes, the gateways, the network server, which includes the network controller, join servers, and the application servers and customer servers, which is like totally optionally, as you can see in figure. So this is like the main setup of the IoT and LoRaWAN system. So which helps to like monitor the network side and any suspicious activity which is going to happen on the network, and help to maintain like all the accuracy and the security of the environment of the data. Can I move to the next slide? So if you see this chart, over the time from, if we see from 2008 to 2025, 2018 to 2025, so like the devices which are like building, it's increasing like year by year, because as we are like moving in the AI era, and where like everything is like converting into AI, every system is like using AI systems. So, like the risk of the data getting stolen by the AI or the unauthorized users is increasing. So, the use of IoT growth, IoT devices has this type of devices is like needs is increasing year by year. So, to elaborate it more, I'll call my next teammate, which is Saad Ahmed. So, he will like explain a little bit more from the next slide. Let me pass to Saad Ahmed.
Hello everyone, this is me Saad Ahmed, and I'm going to talk about security threats is IoT, especially in all our own networks with more devices connected. Securing them is a big challenge. So I will also show you how using AI-powered IDs IPS at the edge can help protect these networks. Let's take a look at it, how it works. So uh, first of all, we are going through towards an overview. So we have some points like interference, spoofing, packet injection, and denial of services. So from interference, IoT devices that use LoRaWAN are susceptible to interference from other devices operating in the same frequency band, leading to degraded communication and packet loss. So similarly, we have spoofing, we have we can do packet injection, and there are some denial of services as well. So if we can see in denial of services, we can see attackers can flood the network with excessive traffic, overwhelming the available bandwidth and causing legitimate devices to unable to communicate, thus disrupting critical environmental monitoring system. So this was a little bit of overview. So let's talk about other things from the next slide. So we can see here in the next slide why IDS or IPS at edge computing level are important. So edge computing allows IoT devices to process data locally, reducing latency and ensuring faster responses to critical events. Whenever critical events happen, these kind of IPS or IDS are going to give faster responses. So, and in the next point, by deploying AI-based IDs, IPS systems directly on edge devices, threats can be identified in real time, reducing the risk of data tampering and malicious activities. With this kind of like AI-based IDS or IPS, we can reduce the risk of data tampering or malicious activities. So this will be a major feature for us. So, and the next thing, the key benefits of edge level IDS IPS include lower response time, reduce the reliance on centralized security measures, and the ability to continuously monitor traffic for anomalies. And let's move towards the next slide where we can discuss about AI-based systems, how AI-based ideas or IPs offer which kind of advantages. So with AI-based system offer higher accuracy, we can achieve higher accuracy in the to find errors or to find threats. With AI systems, we can the accuracy is going to be increased. So AI system detect 92% of threats compared to 70% for traditional systems. So this is a huge difference. With AI systems, we can detect 92% of threats, and with traditional system, we are going to um, uh, we detect like 70% of the systems. Then in the next point, fewer false positives. A reduces the rate of false alarms to 5%, allowing security teams to focus on real threats. Like with this kind of by using artificial intelligence in our system, we the false alarms rate is going to be below 5%. So this is a huge plus for anybody or any organization to use AI systems. The next point is lower latency. AI-based system process traffic more efficiently, reducing detection latency by up to 70%. And the last point, which is energy efficiency. AI models optimize resources use, which is crucial for resource constrained to IoT devices. So the next part is going to be explained by Santosh. Santosh will be going to explain the next part. Thank you very much.
Yeah. Thank you, sir. This is myself, Santosh here. So I'm going to explain about the literature review over here. So the literature review provides valuable insights in the AI-based ideas or IPS solutions. Despite advancement, many of these solutions are like not fully optimized for resource-constrained IoT devices, and some focuses on centralized detection. Like, and moving on to the next slide, we can see the achievements and shortcomings from our project. Like now we can see the improved threat detection, which means machine learning models can learn from high historical data to identify complex and evolving threats, offering higher accuracy. So when it comes to real-time analysis, AI models can process data real-time, allowing for faster threat detection and response. And when it comes to the adaptability, the system continuously improve over time through training and enabling themselves to stay ahead of evolving threats. And the next one is a resource constraint. Many IoT devices lack the processing power and memory to run AI models efficiently. So the model updates are like AI models need to be updated regularly to keep up with the attack vectors, which can resource intensive and difficult to manage in large scale deployments. So when next, moving to the next slide, we will be having a research methodology. In this, we have five types are there. One is the data collection and AI model development, federated learning, model development and validation. So first comes data collection. It's like from publicly available data sets like TON IoT and LSS KDT to train the IDS or IPS models. AI model development, we employed like TensorFlow and PyTorch frameworks to build anomaly detection models. So for the federated learning, this approach allows for the decentralized training of the system. Instead of sending raw data into the cloud, the local devices train their models and only share the updates within the central cloud server. So model development, when it comes to the model development, once trained models are deployed on the edges with the delta updates sent from the cloud to the edges for the minimal data transfer. And at last, we'll be having the validation. We validate our models in real time, IoT environments, measuring key performance indicators such as detection accuracy, energy consumption, and latency. So next coming slides will be explaining by Jay Prakash from our team. Thank you.
Thanks, Santosh. So this is myself, Jay Prakash. So let's delve into AI-enhanced security for LoRaWAN, key components and benefits. So let's look at the key components here. So let's begin with anomaly detection with AI models. So like this component like utilizes unsupervised learning models such as autoencoders and isolation forests to monitor IoT data streams in real time. So the benefits are like real-time detection, low false positives, and minimal requirement for label data. Label data is mostly required in training the models. So these particular autoencoders and isolation folders do not require uh, fully labeled data. So next, when we look at the adaptive network management with reinforcement learning, we have primarily two methods that we are using here. First is the DQN or the deep queue network, and next is the PPO or the proximal policy optimization. So these are used to dynamically adjust the parameters to optimize the network power, bandwidth, and other security configurations. So this will help to optimize both the performance and the security. Uh, okay, next, when you look at the benefits, these provide like proactive security management, they are adaptive to evolving threats, and perform like optimal resource utilization. Since they have like continuous learning in the reinforcement learning, they can adapt to changes very quickly and provide these benefits. So next, when we look at the third component, which is the federated learning for distributed security. Um, this particular component leverages federated learning, which where AI models are trained um, locally on the devices. So federated learning is nothing but where the actions are, and the training is assigned to the end devices and is not performed on the cloud. So this helps with running data locally, uh, and it maintains data privacy. So yeah, these are the benefits and components. Um, Next, let us look at the eco integrity architecture. So these are the five primary components in this eco integrity solution that we are suggesting. Um, First is the cloud AI processing. Next is the edge inference. Third is the LoRaWAN gateway. Fourth is the federated learning, and fifth is blockchain for tamper proofing. So, we are like offloading the heavy computation to the cloud. So all the large scale machine learning algorithms will be run on the cloud, and we will use federated learning to push those updates onto the edge devices so that they can maintain themselves locally and keep themselves secure. Next is the edge inference. Lightweight versions of the trained models are deployed on the edge devices. So these edge devices perform real-time inference, detecting potential threats locally. So these are the advantages. Next, coming to the LoRaWAN gateway, it acts as a bridge between the IoT devices and the cloud. So all the communication goes via the gateway to the cloud. So this also facilitates like secure communication, um, and and the federated learning also happens via this interface. Uh, Coming to the blockchain and for tamper proofing, like we are planning to use the data in the which is recorded on a blockchain to prevent tampering, and each transaction is immutable, uh, ensuring that data integrity is maintained across the system. So these are the benefits. And to conclude, like eco integrity, it leverages the AI-based IDS and IPS to secure environmental data. Blockchain ensures tamper-proof data records and supports redundancy mechanisms, enhancing reliability in IoT networks. Uh, Redundancy mechanisms, they ensure continuous operation and availability in case of device failures or data corruption. Next, moving to the federated learning, they enable privacy preserving updates on local train on devices using local training, and reducing communication overhead, while maintaining a high level of security. And finally, enhanced network security and performance because of reinforcement learning, and they also are trained to perform the AI-based anomaly detection. With this, we come to an end. So we thank the uh, authors of these journals, via which we have adopted many ideas and resources. Also, there are other authors who we like to acknowledge. The complete list will be provided in the report. Uh, thank you for
Thank you.
providing us an opportunity. Yeah.
Thank you
Thank
so
you.
much. Thank you.